Hey, in this video, I'll be showcasing a render I made and the process I went through to make it, starting from scratch with the modeling. So as you might have guessed, this is a pretty simple step. I made some similar bowls before, and they're all basically the same process. I started by grabbing this single reference image from Google and built out the shape of the bowl, starting from a circle. I kept it very low poly at base and used a subdivision surface modifier to smooth it out. I then added a very large scale smooth noise pattern to the displacement input, just using modifiers. I kept this texture very large scale because the higher frequency detail will all come from noise in shaders. Speaking of shaders, they're definitely the highlight of this render. One of my favorite things to set up were the spiraling ridges that go all along the bowl. I made this entirely in shaders, so if you look at it from the sides, you can see it's not in its geometry. All it is, this mask fed into a bump map. But the process of making this mask was pretty fun. As you might have guessed, it starts completely from a sine wave. I then use a radial gradient texture, multiply it by a certain number, and plug that into the phase input on the sine wave. So this isn't just a simple rotation. No matter where you look at it, it will have a spiraling effect, all the way down to the center. But what was this special number that I used down here? Some of you might recognize this as tau, which is 2 pi. That means every single revolution that the spiral takes around the bowl, it's shifting itself down 2 rows. So if we set this to a non-multiple of pi, like 10 for example, we get this misalignment for every revolution. So if we set this to pi, it's actually shifting down not 1, but 0.5 rows every time. But since we're using an absolute node right after it, we're flipping the negatives, giving us a coherent spiral result. But if we take a look at our reference material, this spiral pattern only happens on certain parts of the object, namely this upper half, which we can create a mask for using the z-axis. But if we just multiply these two outputs together, sure, it looks fine on the outside, but the inside has the same effect applied to it. So we need some way for a shader to check if a value is inside or outside of a bowl. And I did this using a simple texture paint. So I didn't actually texture paint the inside by hand. All I did was mark UV seams on the ridge of the bowl and paint the insides fully white, which I then called the inside check in my shader. So now accounting for whether the spiral is outside or inside the bowl, we get an effect like this. And if you're wondering how I added noise to these sine waves, all I did was use a map range node on the sine wave and plugged in this noise into the from min value. And one of the many advantages of using procedural techniques is that I can always tweak this to match the reference better. But I think this matches pretty well. What's likely the most eye-catching part of this bowl is the green inside. Once again, looking back on our reference image, there's actually a surprising amount of detail to this green surface. Just like the reference image, there's actually a slight brown tint to the bowl as it nears this green surface. Looking at the diffuse input, we can see it a bit better. But we'll come back to tackle this brown band only after we've done the green section. The immediate thing I thought of, and maybe you did too, was to take the length from the center, giving us this spherical gradient, which is a good start. But just like the spirals, even though we have it on the inside, it's also affecting the outside of the bowl. So after tweaking the spherical texture itself, I used the inside check, plugged into a maximum node, to limit this effect only to the inside of the bowl. From here, the rest isn't too difficult. Our brown band can now be made just using an absolute node and a map range node. On top of that, I've added some waves to the green texture. I made that just using the spherical gradient with a noise texture. And of course, we can use this texture not only to influence the green part of the shader, but also the bump map. So the bump maps on the shader are pretty intricate. Obviously, we have our spiral made earlier that's fed into the height input. I'm also using a smooth minimum here to add even more softness to the sine waves. But if we zoom in farther, we have one pretty small level of detail here. But that, of course, isn't the only high-frequency detail I have on the shader. What you're looking at now is the clear coat normal input. You can probably tell that this is Voronoi distance. It's pretty simple, but it goes a long way to emulate a porous-looking effect on the surface of this porcelain. On top of that, our base color has quite a bit of noise built in. And when seen from our camera, along with depth of field effects, it looks pretty realistic. And as with any other shader, I have a need to put pointiness masks on everything. So I used this system to add some pointiness on the rims of both the bottom and the top. But you might be wondering how I got the pointiness to work on the spirals, which are made entirely through a normal map. Well, all I did was take the output of the spirals and add them to the pointiness masks. Tricks like these can make the whole shader look pretty coherent. And the reason I'm only talking about the bowl in this scene is because all the other models are just Blender Market assets. This wooden board especially is a big upgrade from the last one I used. And it might look a little funny to take a render that looks like this and reveal that the backgrounds are just two doors side by side. And yeah, that about sums up most of the shader. And I hope, as with many of the other videos on this channel, it shows the flexibility and power of procedural shading.